The title of this presentation is Visible Thermal Motion of Water Around Ice. Can we observe the thermal motion of water? It is shown in the first movie. It was captured with large magnification through a digital camera of Pentax Optio W. Here, the flickering in the movie was decreased through a digital filter of Windows Media Encoder. Why can we observe the fluctuation on cluster water? A cluster consists of the helixes. Those are arranged in parallel. It has an optical rotatory power. And each cluster of water fluctuates by the thermal motion. In a cluster, there is rotational vibration around an electric axis with keeping helical structure. This mechanism will be explained in the next movie, Origin of Life 2.4. The rotational vibration accompanies with the fluctuation of the size, and the rotation is possible to exchange hydrogen atom. At the melting point of ice, the size of cluster is large and the movement is slow. But, at room temperature, the movement of cluster becomes intense, and the size of cluster becomes small. It is considered that visible thermal motion of water depends on the optical axis on each cluster of water. The second movie shows the thermal motion of diluted milk. This movie was captured by means of helical USB microscope. The magnification of USB microscope is small. There are a lot of small vibrating areas around bubble. The size of fat ball of milk is small compared with the bubble. But about 1 micrometer of fat ball is very large compared with the molecule of water. The individual thermal motion of one molecule could not cause the motion of Brownian particle, because the diameter on one molecule of water is about 3 angstroms. The size on molecule of water is too small compared with the Brownian particle. The difference is larger than 3,300 in ratios. The Brownian motion is the thermal motion of the particle. It is considered that the Brownian motion is derived by thermal motion of the cluster, that is nearly same size of Brownian particle.